All right, let's take the next question on mensuration topic cuboid. Okay, let's focus on this and let me change the color of my pencil from red to orange. Okay, red is for something for important, so I don't want to overuse that. Okay, all right, so let's read this question. External dimensions of a wooden cuboid, so we know it's a cuboid problem, are 30 by 25 by 20 centimeters. If the thickness of wood is 2 centimeter all round, okay, find the volume. Okay, this is like the way this question is phrased. Okay, no punctuation. Okay, find the volume of the wood contained in the cuboid formed. Looks like a very wordy problem and hard to interpret what the heck they are saying. But let's assume and solve with our assumption, because I checked out the solution and maybe they're exactly talking what they're thinking. Okay, so let's figure out. So if the thickness of the wood is 2 centimeter all round, find the volume of the wood contained in the cuboid formed. Okay, crazy. Okay, let's do the visuals first. Okay, so I just copied this. The good thing is the problem is wordy, but look at this baby which is smiling, so that should put you to ease. Okay, so let's say I've copied two visuals to play around with that. And although this looks like a cube, but assume that's a cuboid. Okay, I didn't get time to search the internet, so, and that's not important. So assume that it's a cuboid, and this is like the overall view, 3D view. Let's say instead of top view, you can say 3D view, and this is like the front view. If you just take this front portion, it will look like two rectangles placed within each other. Because it's a cuboid, we know it's going to be all the play on rectangle. Okay, so let's try to understand what the heck they're saying. So external dimensions of the wooden cuboid are, they've given the dimensions. That's pretty simple. So I've plotted it here. I've written the question again here. So this 30 by 25 by 20. So I've taken the external dimension over here, 30 by 25 by 20. So that's the external dimension. And if the thickness of the wood itself is 2 centimeter all round, so from all the directions, there's another internal square or internal rectangle coming up, which also takes the form of a cuboid. So you can think about it as a cuboid within a cuboid. And that dimension, the thickness of the wood, is 2 centimeter from all the sides. So I've taken 2 centimeters from this side. Everything in red, if you see, is 2 centimeters from all the sides. And if this view is confusing, you can focus on this. Assume that you're just taking a cross section from the top. And if this is a frame, so this piece is the external part, and this piece, okay, let me see, this piece over here is the internal part. Okay, and this thickness is 2 centimeters from all the directions. Initially, I thought the way I read the question, they're asking us to calculate the area of this internal cuboid, but looks like that's not what they're asking. They're asking us to calculate, let me just erase this. Okay, let me erase this. Okay, they're asking us to calculate this piece, whatever is highlighted. This also forms a small cuboid. It's not that big of a cuboid, but all of this, if you take this here, if you take this direction, this one, this cuboid. So that means, in that sense, if that is true, then we have to take the volume of the external cuboid with these dimensions, and then we have to take the volume of the internal cuboid with reduced dimensions, because it's 2 centimeters. So since we have 2 centimeters from all the directions, we'll have to reduce that, and then we'll have to take the difference. Possibly that's what they're asking, and let's assume that's true. So in that sense, what happens is the dimensions of the internal cuboid, since it's 2 centimeters thick from all the directions, if you want to calculate this inner length and breadth and height or whatever dimension, you have to subtract from the external dimension that they have given 2 centimeters from each side. That means in net it will reduce by 4 centimeters, 2 centimeters from each side, right? It's from all the directions. So that way each of these dimensions, length, breadth and height, will reduce by 4. It will be minus 4, minus 4 and minus 4. This is what I have done here, because we are reducing it 2 sides on each side. So the dimensions of the internal cuboid in terms of length, breadth and height will be this. Okay, it will be this here. So assume that this whole part is kind of equation 1. Okay, now rest is very simple. Let's apply the formula. So we want to find the volume of the wood contained in the cuboid form. So I'm exactly taking the crazy words in the question over here and putting it sorry about that, it was my mouse that fell off. Okay, I'm putting it here, and we know there's going to be a difference of volume of 1 second guys, I think my mouse is acting up. Okay, here we go again. Okay, sorry about that. So we are going to take the difference of the two cuboids, the external and the internal, and for sake of simplicity I put this in the blue color and this in the orange color and the final answer in the green color. Okay, and we know from the very first episode that we did on cuboid, the volume of the cuboid is length into breadth into height, multiply all the three dimensions, and it's going to be cubic units. Whatever is the units, in this case it's centimeter, so it's going to be cubic centimeter over here. We know that. And if you cannot remember the formula, this one is easy, but if you don't remember the formula, volume of any solid object, always assume that it's going to be the area of the base multiplied by height, and which I've discussed why that is. You should think about how much water this can hold or how many objects I can keep in that. And the area of the base is going to be rectangle. So if it's a rectangular base, we have length into breadth and then multiplied by height. So we get area of the rectangle into height, which is length into breadth into height. Or you can remember this formula. So whatever works for you, you remember. And let's straight away apply this length into breadth into height, multiplying all the three sides or the dimensions of a cuboid for each of this external and internal. And this is how we get, right? This is already given in the problem, 30, 25 and 20, which is in the problem here, 30, 25 and 20. And the remaining we already calculated from this point. We have to just take these three lengths and multiply. So the first one gives us 15,000 cubic centimeter. This is the most important thing. Okay, you have to put the unit. It's cubic centimeter, or you can also write as centimeter cube, whatever works for you, because it's volume. There are 3 centimeters, so it will have a cubic effect. You multiply anything 3 times, it becomes a cubic. That's the reason of its cubic centimeter. Okay, and the volume of internal cuboid, again length into breadth into height in orange color. We will take the reduced volume by 4 centimeters each side, and that is going to give us 8736 again cubic centimeter. Okay, and the final thing is we wanted to find what is the answer in green color, volume of the wood contained in the cuboid formed, the difference of both the numbers, 15,000 cubic centimeter minus 8736 cubic centimeter, which equates to 6264 again cubic centimeter, and that's going to be our final answer. So the volume of the cube wood contained in the cuboid form is 6264 centimeter. And in case if the interpretation is wrong, you'll still get the marks because you have calculated all the volumes. So I don't think they can deduct any marks there. So that's the whole point of solving this problem. And like I said, always draw the visuals and place the dimensions on the visuals so that it's clear, and then apply the formula. Either if you have memorized, it's great. If you're not memorized, you know how to compute it in case you forget. And don't forget to put the cubic units or square units, so whatever is that. In this case, it was already given as centimeter, so we'll use centimeter all along. If it's not given, then just put cubic units or whatever that is. And that's kind of the solution to this topic, and then we can move on to the next topic.